Hi there and welcome back. Let us look at molecular shape. Molecular shape is important in determining how a molecule interacts or reacts with other molecules. We are going to make use of the valence shell electron pair repulsion theory. It states that the valence of electrons in a molecule will arrange themselves around the central atoms of the molecule so that the repulsion between the negative charges is as small as possible. It is based on the idea of the geometry or the shape of the molecule and is mostly determined by the repulsion amongst the pairs of electrons around the central atom. We are going to look at some few steps here. We are going to first draw the Lewis dot diagram structure. We are going to count the number of pairs of electrons around the central atom and determine the basic geometry structure of the molecule. For this example, we are going to look at barium chloride. If you locate barium chloride on your periodic table, you'll notice that barium in group number 2 has 4 atomic numbers. If we use the alphabet diagram to determine the valence electron and the co-electron, you will determine the electronic configuration. It's 1s squared, 2s squared. And this means we have 2 co-electrons and 2 valence electrons. Beryllium Lewis dot diagram, it's based on the valence electrons, which are just 2, and therefore hence it has only 2 valence electrons around its structure. If we also go to chlorine, you'll notice that it has 17 atomic numbers and it's in group 17. It has 7 valence electrons. Its electronic configuration can be expressed as thus, with it having 7 valence electrons and the remaining being the inner or the core electrons. If these two were to react, they can be expressed as, looking at this Lewis diagram here, if we were to count the number of electrons and the lone pairs, we can say that there are 2 pair electrons around the center and 0 lone pairs. And hence, therefore, to determine the basic geometry of the molecule using the table, with A representing the central atom and X representing the terminal atoms, the atoms around the central, we can say that beryllium chloride, it has 2 electron pairs around it with no lone pairs, and therefore the geometry is linear, with the general formula being AX or AX squared. In this case, we have AX squared. You can also explore the molecular shape and the 3D shape. I really hope this makes sense. Thank you so much for watching.